We're starting now. As my father would say, no talking aloud. I have a father.
You were born and raised.
I was not genetically manufactured.
Bash.
Okay, Bash. So first of all, some of these examples are from this website. I don't know if it's still there, linuxconfig.org, but
Let's check it. Like a website for old people.
it might have been there.
It's
Anyway,
still up.
what we're talking about today is arrays in Bash. So arrays are, you all know what arrays are in other languages. They're similar in Bash, but also
That's at one point and goes on forever.
well, yeah, there's no exact size of an array. It's an array is not limited in size like you might have in C++ or in C. So, for example, there are two kinds of arrays: indexed arrays and associative arrays. You probably know indexed arrays from C++. I don't think C++ has associative arrays. So it's a new,
Basically,
but maybe you have it in another language like Python or something, or PHP if you know PHP. Yeah, you could call it a map. But let's distinguish between the two of them. The normal way to declare array is to write the word declare minus a being array, and then the name of the array you want. So that will create an indexed array called myArray, which means that you can go to location 0, 1, 2, 3, etc. There's another kind of array which you say declare minus capital A myArray, and this is an associative array. What is an associative array? Well, I'm going to give an example, so we'll see it when I give the example. But it's not with indexes, not with normal indexes, and you have to write the capital A here. And notice it says using declare is the only way to create an associative array. There are other ways of creating an array. In fact, I don't have to even use the word declare minus a to create an array. I can just write my array equals, and then if I give it a bunch of elements, it knows that it's an array. So I don't have to use the declare at all if I want an indexed array. But if I want an associative array, I do. So here, let's see an example of right away of an associative array, because that's the one you don't know maybe. And I can say like this: declare my array with the capital A, so it's an associative array. So look how it looks. Banana equals yellow. So what this means is the index is banana, and the value is yellow. And then I have another element, coconut equals brown, and lemon equals yellow. Notice that I can have the same value twice, yellow and yellow. I can't have the same index twice. I can't have twice bananas in the array because then we would know which one I'm referring to.
But it can't just be indexed differently. Like it can't just be like banana is just a 0 index.
When I'm using banana as an index, I can't have it twice.
Isn't that just like a hash map?
If you want to call it that.
Like, isn't that like a fundamentally different data structure than an array?
Well, it's in this language, it's considered an array.
That's absolutely wild.
It's an array, which is called an associative array. It's not called a hashtag or hash table or not called anything else. I mean, you could think of it as other things, yeah.
Oh, you declare the difference as a capital A or lowercase.
That's what I said, yes. It's capital A and lowercase a. A regular A, here's the regular lowercase a, my array, and I say this is optional because if I wouldn't have this line and I just wrote my array equals, and then I wrote in now the key thing is I have the parentheses here. Parentheses, banana, coconut, lemon, then it knows that it's an array. If I would write quotation marks here and quotation marks here without instead of parentheses, what would I get? What would I have? I'd have a string, and what would my array be?
A string.
Right, it'd be a variable. It wouldn't be an array, it would be just a variable. Now it's an array this way, parentheses. So now look what I can do also. I can say my array at place 3, which of course doesn't exist. 0, 1, 2 equals papaya. So I've added something to the array. Here I can do the same thing with my array, but I have to specify my array, and I can tell it the location papaya equals green. So I added a value. Actually, both of these I put in the index. Are papayas green? Not, I think if they're ripe, they're yellow.
It's papaya.
Okay, so now we get into complicated stuff. To print the values of an array, to display all the values of an array, use the following shell expression syntax. So I can write echo, right? Now we're in the shell. So the shell is a bash shell, so it's actually built for using bash programming. So I can say echo, in fact, this would be a command in a bash program also, echo dollar my array, and then instead of giving it a particular element, I gave it the @ sign. And the @ sign means all the elements. So that will print all of the elements. I could also use the star. So you'll say, is there any, so the question you would ask normally, is there any difference between using the star and the @? They both will produce in these examples the same result. But is there any difference? So so here's what so I relate that. Both syntax let us access all the values of the array, produce the same results, unless the expansion is quoted. We get into interesting cases where you put it in quotes. You might want to put it in quotes. In this case, a difference arises. In the first case, we're using the @ symbol. The expansion will result in a word for each element of the array. This becomes, in other words, we'll get a new word for each element. This becomes immediately clear with a for loop, as in this example. Imagine we have an array with two elements, foo and bar. So we have an array with foo and bar. And then we do like this, for I in, and then I write quotations. If I wouldn't write quotations, then both of these would be the same. But I wrote quotations here. For whatever reasons, I wrote quotations here. It could be because I have I'll give you an example why I might write quotations, because I might have an element that is blue-green, right? And our value that's blue-green with the space in it. If there's a space in it, I need to put quotations so that it knows that it's one element and not two elements. Because it normally thinks of a space as this separator between the elements. So if I write, for example, here, but in my case, I just have foo and bar, two elements, fine. So it's going to print do echo $I. So it's going to print each element one by one. So it prints foo and bar. But if I use the star and I do the same thing with quotation marks, it's just going to print foo bar as one line. Why? Because it's as though I wrote for I in quote foo bar quote. Well, foo bar quote means that treat foo bar as one element. So it'll treat it as one element and the loop will only run one time. But here, even though I had quotation marks, it knew to treat each element as a separate item. That's the difference. A subtle little difference. In fact, most of today's lecture is about subtle little differences. Okay, so it's also possible to iterate over part of an array with the new double parentheses operator like this. So originally Bash did not have this double parentheses, but they added it because people were used to C and C++ and wanted to be able to type in that style. So you can do a for loop, and with double, this is not like what you would call nested parentheses. This is a special symbol called parentheses. And once I've written that, I can now write C++ style. So I wrote I equals 0, just like I would normally say, but I have to still, when I refer to that variable, I still have to refer to it with $. Of course, in C++ you could also do that. I mean, you have to write $1 here. So it's kind of a mix, but the basic idea is that it's C++. But you notice that I do have to refer to it with $. As long as $I is less than, what does this mean? So you actually should know that from the videos that you watched. What does this mean? Remember? Well, what is this called in English? Number sign. It's one name for this is number sign. So it's the number of elements. I believe. Do echo index. Sorry, do echo. So we're going to go through this loop twice, and we're going to print my array at location I, where I start off being 0 and then 1. It'll go through twice. So this is actually the number of elements in the array. When you put that number sign there, it means how many elements are in the array. Because otherwise it wouldn't make sense. Otherwise, what am I saying? Is I is greater than, this has to be a number. Right? This has to be a number. Shy, you okay? Okay. Print the keys of an array instead of the values. So now, you have a question? Yishai. Yes.
Why do you only need the $i in a condition and not like for I equals 0 and I plus equals 1?
Because we had a rule in Bash that when you assign a variable a value, you don't write the $. And when you use it, you do write the $. So these cases are assignments. This is an assignment, and this is also an assignment. That's why. It's just a rule. When you assign it, you don't write the $sign. Okay. Here's another example. Print the keys of an array instead of the values. Only works in conjunction with the @ or the star. So here I made an array, a regular array. Notice it's not a associative array. I didn't even declare it. I just wrote array equals my array equals foo bar for index in. What does this mean? This exclamation mark. If I would have not written the exclamation mark, what would I have gotten? I would have gotten the element. My array in other words, this is a list of all the elements. So for index in a list of all the elements. So the first time would be foo, and the second time would be bar, and then the loop would stop. But by writing the exclamation mark, I'm saying not the index, but the thing that's indexing it. In other words, not the number, not the value, but the index of the value. That's what this means, the exclamation mark. So I got 0 and 1. In other words, it gives me the index of it. Right? If I wouldn't have the exclamation mark, this would be the element. By writing the exclamation mark, I'm saying, no, I don't want the element. I want the thing that refers to the element. It's kind of like, I don't know, dereferencing, whatever. It's like, I want the indirection of it. I want not the thing itself, but the thing that points to it. What thing points to the first element? 0. What thing points to the next element? 1. And then I print the index. So here's how you can print the index of the array. Fine. The same is valid for an associative array where it's more useful. I mean, I don't really need to normally print the indexes of an array. But if the array has indexes that have values, like foo and bar, remember my other example was banana, green. Let's say what you call a map. I want to know both elements of the map. What maps to what? Right? I could have phone numbers, I could have area codes, and listed to the counties that those area codes are related to, right? I have a map. So in this case, I want to print the foo and the bar, not the banana and the coconut. So I do the same thing with the exclamation mark, and I get bar and foo. Why do I get bar and foo? No, notice that I got bar and foo and not foo and bar. Why I shouldn't have gotten foo and bar since I created the array foo and bar? Well, the answer is that there's no guarantee about the order of associative arrays. Unlike regular arrays, they go sequentially 0, 1, 2, but associative arrays, there's no guarantee about the order. You might suppose that the order is alphabetical, which is possible, but officially there's no guarantee about the order because there's no meaning to the order. There's no relationship between them. There's just one could be some word and another is another word. There's no who says the relationship is alphabetical. So it may be alphabetical. Probably more times than not, it's alphabetical. Okay. But the computer can store it any way it wants. Getting the size of an array, number of elements. So we already actually. My array, foo bar bas, we want to print 3. So we want to say the array echo. The array contains something elements. What's this something? It's going to be 3. Why 3? Number sign of the whole array. So a number associated with the array, which is obviously the size of the array. Right, because this is the whole array. This is the number of the whole array. That's what I write here. We retrieve the number of elements in the array instead of its contents. Adding elements to an indexed array with the plus equals. We saw an example of adding an element by saying at index number 3, put in this value, even though there was no index number 3. Here we see that I just say, here's foo bar, and then say array plus equals bas. So now if I print the whole array, I'm going to get foo bar bas. And I can even do like this, my array foo bar, and then add plus equals 2 elements, bas and foo bar. So now I'll get all 4 elements. Fine. Pretty straightforward, but interesting. I mean, you can't do that in C++. To add elements to an associative array, we must specify their keys, right? You can't add elements to an associative array without giving a key, because what's its key? It's not gonna. There's no default keys. So if I have an array with just one element, foo. Notice that I had to do this. I had to do declare in order for this to work. Then I can say element foo, his value is bar. And now if I want to add more, I can say plus equals bas foo bar and foo bar bas bas. Deleting elements from an array. So here's another unique thing in Bash. I can do unset. If I unset my array at 1, what element is going to go away? Bar. Because this is 0 and this is 2. So when I echo the whole array, I'm going to get foo and bas without bar, because that was the element I unset. Now the interesting thing is when I print, remember how I can print all the elements? I mean, all the indexes? Look at this weird thing. I print indexes 0, 2. What happened to 1? Well, I unset it. So it's an indexed array with gaps. It's not like there is an element there and it's just 0 or something. It's just no element there. There's 2 elements in the array and they're at indexes 0 and 2. The interesting thing, you can try at home, adding an element to this. Where will it go? Will it fill in the gap or will it go to 3? The same thing is valid for associative arrays. Associative arrays, it makes more sense, right? I have my 2 elements in the array. I unset one of them. When I print the array now, I only see one of them. If I would print the indexes, obviously I would only see the one index. What about deleting an entire array? So this is actually very important because sometimes you declare. It happened to me once. I was typing on the command line, creating all kinds of arrays, and then I came back later and I didn't realize that something was not working the way I thought it would, and it was because the previous array was still around. Until it never went away. So sometimes you want to delete an array so you can like clear your memory. So unset my array. So that would get rid of my array. And now if I do echo the number of elements in my array, it doesn't even print me 0. It prints me nothing. Why it prints me nothing? Because there is no array like that. It's not like the element has 0 elements. You could theoretically have 0 elements. If I would delete the elements of the array, then it would have 0 elements. Shai, you tried it?
It's
Not working?
well, we trust you. Yeah, I made mistakes.
When trying to print its content, an empty result is returned.
Yes, sir.
Right. When I try to print the array, I just get nothing here. Because it's not there. It's not an error, by the way. Right? I can always print a non-existing array. It will just give me nothing. It's not going to tell me undefined array. All right, here are some examples. What is line 2 going to print? This is an array of 1, 2, 3, 4, 5 elements. Notice that I didn't have to write -a because it's a regular array. What will this line print? So what will it print? What number will it print? What will this print? 5. Exactly. What will this print? Echo. Don't look at the answer. Try to figure it out. Number of 2, what do you think that's gonna print?
Two.
2, why would it print 2?
You can't see what from here.
Well, then come closer or follow along on your computer because these slides are on Moodle. You can't see. What will this print? What do you think this will print?
3.
By 3, the size, the length of the elements at index number 2.
Oh,
1, 0, 1, 2. What's the length of this?
4.
4. So it's going to print 4 because it's element 2. And but not the element itself, the size, the number of it, the number associated with it, which is its size, so it's 4. What's this one gonna print? This one printed me the number of elements in the array, the first one. What does the third one print here? Number array 2. It's a tricky one. You would not really be able to guess this. But if you remember in C++, we said the name of an array points to the first element of the array. So this is the name of the array, so it's pointing to the first element of the array. So the first element of the array is 1, 2, 3, 4, 5, 6. So the number of it should print what? 6. The size of the first element in the array is 6. Now what about this one? Temp equals what? What is temp going to get? What value? What will be the value of temp? Array 2, the whole array, colon 3.
First 4. First.
Not the first.
Last 0.
From index 3 on. So 0, 1, 2, 3. It'll be this one and this one. Now, when I print temp, it prints 4, 5, it prints those 2 elements. Why did it do? It did that because it really should have, what should it have done? It should have maybe printed like the first element. Why did it print both elements? If the name of an array is pointed to the first one, it should have printed the first element. Why did it print both elements?
Because it started at index 3, you know?
Yeah, it started at index 3, that's true, that's why it's printing these 2 values, but why not just print this one? Why did it print both of these?
Kasha. Because temp is now the array.
See you for the slides.
Yeah, but this is the name of the array as a pointer to the first element. Why did it print both elements of the array?
I do not know.
I have a question.
You hear the question. You gotta hear the question before you can hear the answer. The answer is that temp is not, that even though I assigned it from an array, temp itself is not an array, it's a variable.
What?
It got the values, it's essentially a string of the 2 elements. So it's just what's the string? How could I make temp be
An array?
an array? So that's what this last example here is. Look at the last example. I put the same exact thing as I did here,
Oh, you put it.
but
in
I put it in
parentheses.
parentheses because the parentheses is, remember how you declare an array? Is with parentheses. So if I declare if I say temp equals parentheses, oh, now temp is an array, it'll know to put both elements as 2 separate elements in the array.
Is that okay to work with one element? Like if I just.
Yes,
have
yes.
array,
And then if you print it, then it'll just print.
Now if I printed just $temp, it should print me the first one. But before we get there, look at this other example. Or actually, we're not going to get, I don't have an example of that. But look at this other example. Temp 0, 1. What do you think that's going to do? If temp is this whole thing, what will temp 0, 1 do?
What is string?
It's a string, but when I do colon on a string, review the
Number of
videos.
letters.
Review the videos from
From
the vacation one. And it's which print variables from index 0 for 1 character length, i.e. 4. In other words, this 0 means which index, it's like a substring of a string. I don't know if you ever learned that function in C++. There's a function in C++ called substring, where you can take a long string and say, give me from the 6th element, so 6th letter in the string, give me 10 letters. That's what part on a substring. It's called substring.
Yeah.
So that's what this is. 0 means from the first element in the string, 1 character long. So it's going to give me the value 4. this 4 will print. You understand? Benny?
No. Alright.
You understand the kind of substring? Let's say I have hello world and I just want the W.
Oh, I thought 1 was the step up, because you're just printing. If I'm 0,
0, 1 means from the beginning, 1 character long. If I write 0, 7, it would print these 4 plus the space plus 2 more numbers.
Yeah.
All right, so those are review questions. Here's another example. Here, Shai, look at this. Another example of an array. And I use 2:2:2. So this now, when we're referring to an array, it doesn't mean from letter 2, from index letter 2, no, from the third letter, from letter 2, 2 letters. It means from index in the array 2, because it's an array. Now the meaning of the :2 changes depending on what I'm acting. Since I'm acting on an array, it knows the second element. So what's the second element? Well, it's 6, 5, 4, because this is the 0, 1, 2. And then I wrote 2, so it only asks for 2 elements. So it's these 2. So I printed 2 elements of the array. To copy an array, how would you copy an array? So one way would be to iterate over the whole array. That's how you would do it in C++, right? In C++, you would make another array of the same size and then copy 1 by 1 each element. There's no other way to do it. But here we have another way of doing it, which is what did I say? The following will make an array with 1 element. The declare does not help us here. Here I write declare array. It's an array. I wrote Q equals the whole array. Is Q a copy of this array? Kind of, but kind of not. Why? What is Q? What is Q? Is it an array or a variable?
it's array.
It's an array. How many elements in the array?
Same amount.
The same amount as array 2?
2.
No.
No, 1.
1 element. Why?
Oh, from 2 to 2.
Why? Why is there only 1 element? It's not 2 to 2. I'm taking down here. You're behind.
Behind.
Here. Why is only 1 element in the array? What did I forget?
Parentheses.
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 It didn't, even though I gave it this whole structure, it views it as just a list of letters. In order for me to tell it, no, each one of these are space delineated elements in an array, I need to write parentheses. So what will happen here when I print Q of 0? It'll print the whole array, because it'll print the whole previous array, because the first element of the array contains everything.
That's not an array, it's just a variable.
It's not a variable. I did write declare minus a. It's a variable. It's an array. It's an array of 1 element. You're right. It doesn't seem to be very different from a variable. That's a common mistake, or mistake that you could make. All right. Bye-bye.
Bye.
Now we have another new thing. So in Bash, we already saw the single brace, the single square brackets. And what is the single square brackets for?
It's for testing.
Testing. What kind of a test? Okay, well, Boolean is like a condition in an if something. And it actually is it's actually like a program. The single bracket on the left is a program in bin.
Isn't that the jankiest thing in the world?
It's a weird thing. That's why I emphasize it. I emphasize all things that you are not intuitive. So, in fact, this is a major thing. PHP adopted the same, not PHP, Python adopted the same idea as Bash, which is to use precompiled functions to make it run faster. Because when you're in a language that is interpreted and not compiled, it's going to be slower. But if every call that you do is to a compiled function, then you don't lose so much in speed. Because you're basically, most of your work is being done by compiled programs. So the single brace is the test. The double brace is again not a concatenation, not nesting. It's not like two of the other ones. It's a whole new command. And I call it, or it's called new test. A new version of test. You could call it new test. Because Bash has been around for 40 years or more, 50 years, but things do change. So they added a new test. So it's a syntactical feature of the shell. What does that mean? Syntactical feature of the shell.
It's not a program.
It's not a program in bin.
It's synthetic.
It's part of the language. So it has some special behavior that the regular single one doesn't have. You no longer have to quote variables like math, because the double bracket handles empty strings and strings with white spaces much more intuitively. In other words, I said before, actually in today's lecture, that when you have a space in a variable name, it'll think it's two variables when you refer to it, unless you put it in quotation marks. Then it knows that if I write quotation $A, and then A happens to turn out to be hello world with a space, it'll know that it's two. When it gets that value, it'll know that it's a single value. If I wouldn't put the quotations, it wouldn't know. It would think that hello is one and world's another. When I use it later. But here, with this one, you don't have to do that. So if I might have previously wanted to check, let's say I got a list of all the file names. I did ls, and I got a list of all the file names. And some of the file names were single words, but some of them were double words. Like I had a file called my homework. I don't know, I had a file called with a space in it. So when I would do the normal test, what is the -f test? This is from the videos that you watched. File, is it a file? So we would check, is the first file that it would look at would be my, and the second one would be homework. And both of those don't actually exist. There is no file called my, there's no file called homework, there's a file called my homework. So therefore I put it in quotation marks to be on the safe side. In other words, in case one of the file names has a space in it, I better put quotation marks here. That's the way we would have done it with the old test. The new test, I can just handle it regular, and magically it works. Why magically? Because it's part of the language knows how it's been designed to deal with that. Okay, that's the first difference. Why am I explaining this? You could say, just teach us the old one and that's enough. Or just teach us the new one and that's enough. And the answer is, my best answer, so far, unless you guys give me a better answer, is that sometimes you'll be Googling something or asking ChatGPT to solve something, and it'll give you a version with two braces. And sometimes it'll give you a version with one brace. And you want to understand why you use one brace, two braces, what's the rule? You think, oh, you get confused. You don't try to, because you don't just copy the things that you're given like an automaton, you try to understand what you got, and it doesn't make sense to you. So this way I'm trying to explain that there are these two different styles, and you should be able to understand what's going on. So here's one difference. We're going to see four differences. The next difference, because it is a syntactic feature, it lets you use the double and the or operators for Boolean tests, and greater than and less than for string comparisons. It cannot do, the regular one cannot do this because it is a regular command, and these symbols are not passed to regular commands as command line arguments. In other words, you can't have an argument to a function with these symbols. But you can if you use it. So in other words, if I want to have a number, let's say a variable is greater than another variable, if I use this symbol, the double symbol, I'll just use a greater than sign, or this is the greater than sign. How would I do it if I use the single one? Again, this is based on your video that we saw. How do I do it? Minus, I do a minus flag, I do it a flag. What's the flag for greater than? You could guess. GT. Greater than. So I would do variable minus GT variable. That would work in the old one. In the new one, I can just do the symbol. All right, third difference. And the new one has a wonderful symbol called equals tilde. I think you have that in Python. No, you have equals tilde in Python? Anyone expert in Python?
No. That's not question, that's just Bash.
That's just Bash?
Equals semicolon.
You have it in PHP, I don't know.
That's
not true.
Walrus? Okay, guys, what does the symbol mean?
There is no.
Alright, for this, what does the symbol mean? Equals tilde, what does it mean? It's for doing regular expression matches. Now, I think we talked a little, did we do regular expressions in the video that you saw? Did we do it in the? Did I?
We all know about regular expressions.
You think you know, but you don't know. We better do some today. We better do some today. But regular expression matches. So for example, I can do, here, look at this regular expression. What does this mean? If answer equals tilde, that's for regular expression matches. What does this symbol mean? This little caret, it's called a caret. CARAT. No. Or ET, I don't remember. No, there's three. You know that you can spell carrot 3 different ways? CARROT is a vegetable. CARAT is the diamond. CARET is this symbol. So this symbol is called a caret. What does it mean? What does the caret mean? No. Starts with. It's an anchor. It's called an anchor, and it means starts with Y. What is, and then parentheses ES question mark. What is parentheses ES question mark?
You can have it or not.
What does question mark mean?
If you can or cannot.
Means 0 or 1 times. 0 or 1 times. So this would accept something that would be either yes or just the letter Y. But would it accept yes, ES? No. Notice how I had to do it with the old one. With the old one, I had to say if answer equals Y minus O or answer equals yes. I don't know. Either way, I consider it yes. But here I can, with one line, answer equals the regular expression Y ES question mark and $$ at the end. What's the $sign
So
mean?
if you want a parenthesis.
End of the line, because I don't want it to be yes, yes.
So if you want a
I
parenthesis.
want the whole line to be just the word yes.
If you want to include a parenthesis in the reference, you have to escape it.
Yes, yes.
That's where it's.
If you want to include a parentheses in the regular expression, you have to escape it. With a backslash. It even lets you access the capture group, which it does in Bash rematch. For instance, rematch Bash rematch 1 would be ES if you type yes in the above. In other words, this is a captured expression, the parentheses. It's like what I found when he typed yes. If he typed just Y, then Bash rematch 1 would be null, it would be empty. But if you type yes, it would be ES. Okay, and you get one more thing, pattern matching or file globbing. I think we talked about file globbing in the lecture, in the lectures, the recorded
What
lectures.
about case sensitivity?
What?
What about case sensitivity?
Regular expressions are case sensitive, so you'd have to, they are, so you'd have to write up,
Why?
you'd have to add that as another option. You could do that with braces. Whatever, with single braces, and you could write Y, capital Y, and then close brace, or a bracket, square brackets. Anyway, if your answer, so here I get like this. File globbing, maybe you're less strict about how you type yes. Maybe you're okay if the user types Y anything and it works. You could type Y, you could type yesterday and you'll accept it as yes. So if you want to accept yesterday and yes, and anything that starts with Y, then you can just write equals, not equals tilde, equals Y star, and then you get not regular expressions, but file globbing. Keep in mind that this is a Bash extension, so if you are writing SH compatible scripts, in other words, SH is like shell. Bash is a version of shell. The original shell is just called SH. And if you want to be compatible to SH, none of this is gonna work. So you better stick with this single bracket. So if you want your script to be not multi-platform, but more versatile, be able to be used by more versions of shell, then don't use this. So you have to be sure that you have the shebang line in bash to be clear that you're using bash, and therefore you can use the double.
Could we use the shebang in the previous one? First, we come with the scripts, the word dot AWK or dot sh.
I never require, the whole course is bash, we're not doing that, we're not doing this, I mean, the dot sh ending of the file doesn't necessarily mean anything.
Bro, what's going on?
I'm just asking because I'm wondering why.
So here's some examples. Here's some examples in old bash and in TC shell. To check for substring within a string, you need to use a grep like this. So look what I want to do. I want to find, here's my string my apple. And I want to find if the string my is in that string. This might be helpful for the homework. If echo string, so the if is going on this whole thing. So echo string, so first thing I do is I print out the string and I put it into a pipe. Now grep comes along and reads from the pipe and checks for the word my. And I give it the -q flag, which tells it to be quiet, which means don't print anything. Quiet in the sense, don't print anything, but do tell me true or false. The true or false value, Tusk, turn around.
Sorry, yes, sir.
Oh, Tuss,
I won't print.
called out.
The -q means file. Nachum, what does the -q mean?
That's, I can see it.
You should be following along on your computer. What is the -q?
Ah, it's flag and bash.
What does it mean?
It means be quiet.
Quiet,
Don't print
means be
anything
quiet
out.
and do what? Instead of printing out the result of the grep, print out what? Well, not print out anything, but return what?
Return a successful status code.
Yes, true or false, true or false, and the if, of course, wants a true or false.
Boom, how's that?
So it gets true or false, and if it's true, it'll print it's there. And then close if. But in a new bash, you would just use the regular expression matching. If the string matches to the regular expression my, which means that my is in the string at any location, then it's there.
You have the space after the total?
Yeah, I don't, are you required to have a space after the tilde? I don't think so. But that's a style in any case.
Oh, dash.
That was messing me up.
Quiet. You weren't good.
It means don't print anything out.
It just the exit statement.
Okay, so here we have a thing that's really best explained with a terminal, so I'm gonna open the terminal.
Open.
In admin mode or like
I don't have admin mode here.
okay.
That was a concept used by the shell.
Okay, let's look at this terminal here, and here I am in the Linux terminal, and if I do a command like WC, and I hit enter, it's waiting. What is it waiting for? Well, normally I would give it a file name, right? I would normally have written something like WC file, and then it would count the file size and tell me how many lines and etc. But if I don't write anything, then it's waiting for some file to come in as a stream, as a input stream. So let me give it a file. I'll just show you that works. Like if I write hello world, and then I type goodbye, and I hit enter, and it doesn't do anything. How do I tell it the end of file? EOF. Control D. And now I sent it an end of file symbol, and it knows to now count, and it tells me 2 lines, 3 words, and 20 characters.
That's the operation that we have to do with AWK, right?
What? Yeah, what? There was AW to do this in AWK? Yeah. To do it with WC, yeah. Okay, so this is this program WC, which you were supposed to do a version of. Okay, so if I just type WC, it's running. And notice that everything I type here, I'm not actually talking to the shell. It's just the file that it thinks. What if I want WC? What do I want to suspend WC? I don't want to kill it. I just want to freeze it so that I can type things. So I can do Control Z. And now it says Control Z. It now says stopped WC and it says 1 over here. That 1 means it's the first job. So I can now type stuff. And the WC is still there in not running, just frozen. If I want to bring it back to life, I have two choices. The normal one way, or the normal way is FG, which means foreground. That means bring it back to the foreground, make it run again. So now look, it tells me WC, and I'm back in WC, and I can type hello world. And I can type good, and I can type Control D, and it worked. Interesting that it gave me 3 lines, not sure.
More creative.
I guess it counted WC as a line. Right?
acho que não tá não?
אני לא כתבתי את WC.
לא, בהתחלה למעלה.
Oh, right, thank you. Okay.
Why did it?
Yeah, it counted this line, the GFDG, obviously it counted, I just forgot about it. So that's the 3. It didn't count the WC. So,
Why does it show up that?
why does what show up?
Oh.
Okay, so that's foreground. Now, if I type WC and I do Control Z, it goes into the background. And if I type BG, that means bring it back, but in the background. And that's kind of weird because you can't have WC run in the background, so it tells me stop. In other words, it went anyway back into the background, or it stopped it again, and I can still do now foreground, and it comes back. Because you're not really allowed to run WC in the background. It's not a normal background job. A background job is usually something that doesn't, something that doesn't connect to that is allowed to detach from the terminal. That's the technical term. Anything that can detach from the terminal can run in the background. What does it mean, detach from the terminal? It means it doesn't care about the terminal, it's just running. For example, some program that's, let's say, waiting in the background for internet connections. And people log into my server and then that program gives them data. It's not interested in the screen at all. So it's running in the background. So some programs you want to run in the background. So one way to run a program in the background is to type, but let's do Control. How am I going to kill this now? To the foreground. Control D. There. I gave it nothing. Okay, so if I write a name of a program, I type program, and then I type, and then I run it, and then I hit Control Z, and then I do BG, it'll run in the background. But a simpler way is to just do like this. Right, an ampersand. And first it didn't find the program. It tried to run it in the background, but command prog not found. Did you mean frog? That's interesting.
You know that one?
I didn't know that one. Let's try frog.
You know the frog?
Let's try frog. I never heard of frog. No, it says you have to install frog.
Oh, let's install it.
I can't install frog. I don't.
I'm not installing those.
I'm not an administrator on this server.
So you can make a virtual environment.
All right, so let's go back to the slides.
Everything now.
Slideshow.
Yeah.
And here is this concept called jobs. Any program that is suspended by Control Z or running in the background is called a job. You can start a program running in the background by appending the ampersand like this, program ampersand. Now it's running in the background. It's not typing, it's not holding the screen. The program would become a background job. To list the jobs you are running, you can type the word jobs. And it'll print you the names of all the jobs in their order. The jobs is actually stored as a stack. So that if you have several things that you froze, let's say you froze something and then you put it in the background and then another thing, or you put many jobs into the background, you froze many things. The last one you froze will be the first one that comes back when you do FG. It's a maxanit, it's a stack. So A program that is suspended with control Z can be started again using FG or BG, like we saw. Here is like quoted from somebody on the internet, I don't know who it is. A job is a concept used by the shell. Any program you interactively start that doesn't detach, i.e. not a daemon, is a job. In other words, if it's fully detached and just running in the background, it's not a job. I started it, the shell, when the computer comes up and the root, you know, the computer itself, the operating system starts many processes and they're running all the time. But they're not considered, they're not jobs, they're just programs that run in the background. And that's what those are called daemons. They just run in the background.
Oh my gosh.
Now we saw this kind of in my example. Control C kills the program. Control Z just freezes it. And FG and BG bring it back in those two different ways.
Not a lot of fun meeting these things. Demons killing the phones.
All right, another topic is XArgs. XArgs is a very nice program. What it does is it stands for execute arguments. So, for example, if I type ls, what am I going to get? The names of all the files in the current directory.
That's so cool.
So if the names of the files are like 1, 2, 3, I'll get 1, 2, 3. Now, if I would pipe it into file, what is file? File is actually, I mean by file is actually a program called file. We learned in the first lecture, there's a program called file, which tells us, what does file tell us? I don't remember.
Tells you all the information of the file.
Which information?
File type and
Permissions.
metadata is a good word.
Permissions. No, not permissions, it's not metadata, I don't like it. Basically just tells you one of two things. Is the file a binary file? Or a
It tells you the
ASCII
encoding
file?
and it tells you
The
the
type.
file type. Yeah,
Would you say the name and the type?
and the encoding.
Encoded, you know, is it an ASCII encoded file? Or an executable file? Basically, that's what you 99% of the time are gonna see. Either it's executable or it's an ASCII file. So file tells me what sort of file it is, what type of file it is. So basically what I wanted to do is file on file 1, file 2, file 3, file, and then the names of the files. If I would just write ls file here, it wouldn't work. Why? Because file doesn't expect a stream of data. Maybe I'll show you, for example, here. If I say ls, and I get a whole bunch of things. If I do ls type file, file gives me an error. File, notice it says usage file. It says you have used file incorrectly. Why? Because file wants to have things on the right side of it, names of files. So for example, if I would write file and then I would type, you know, xmelt. So it tells me, oh, that's a Spark demand page dynamically linked executable file. It ignored the ls because it didn't care about the input. That whole input stream went into this pipe, and file just cares about what's on the right side. It doesn't care about a stream. It's not like WC. See, WC, if I would write WC here, it would take the whole list and tell me how many lines it had, and how many letters, how many words, how many lines, and how many lines, how many letters. How many lines, how many words, and how many letters? It would tell me it would work. Because WC can take either a stream or a file name. If I would type here xmelt, now it ignores the stream and just works on the file. Because what's on the right side takes precedence. But file doesn't work that way. File only looks at the right, so it won't work at all. So how do I make it work? I use the command xargs. And then it works, and it tells me every single file what type it is. What does it mean? What it does is it takes the input from the pipe and it puts it on the right side of the file command. It's called execute arguments. Xarg stands for execute arguments. There's execute these arguments as arguments of the command that follows. So that's the idea of XArgs. So we'll see some more examples of XArgs. Very useful thing. Here, if I type find temp, what does find temp mean? How do you read this? How do you read this line? How do you read this whole line? Until the pipe.
Find slash temp dash.
Well, no, how do you, what does it mean? Translate it to English.
Finds everything in the temp where the name is.
In the directory temp, right, find everything in temp whose name,
Has a core in it
yeah,
and. And is a file.
and whose type is file, right,
Yeah.
and is a file, and
Print it out.
print it out,
So.
Print it out.
Upstream.
okay?
Is it
So that
starts with core or is? Has.
has core in it, you said it correctly.
So it has an error, it's a substrate.
It's like a substring, yes, substring. Now, on those files, I wanna do what command? What's ever on the right here, bin rm minus f, what is rm minus f?
Remove forcefully.
Exactly, remove forcefully, I wanna delete those files. Now, remove expects parameters on the right side, it doesn't want a stream of data coming in on the left side. So I use xargs to switch those variables over to the right side. More examples. Now here's a weird example because WC actually works both ways. WC will work as with a stream and it will work with a file. So I can do both. Here I did ls file 1, file 2. Total WC. What did I get here? Why did it write me 2 here? Let's assume these files are much larger than, than 3 bytes. Let's say they're 100 bytes. So it still prints me 226. Why? Actually, they're 38 and 60 bytes long, respectively. Why does it print me 226? Come on.
Because it treats the left as not an input, I mean, not as a stream, it just as an input. The letters LS, then the next word is F2, and the next word is.
But then that is how many, but it's 2 lines, 2 words, not 3 words, and 6 letters. It's true there happen to be 6 letters, but it says 2 words, 2 lines.
Yes.
Why is it 2 words, 2 lines? What's going on? What's the output of ls f2 f1?
Is the directories F2 and 1.
Right, it just has 2 lines. 1 line is f2 and 1 line is f1. It prints, when you do ls on a file, it just prints the file, right? If I go over here, wait a second, stop. If I do ls xmelt, it just prints me xmelt. If I do ls xmelt xflip, it prints me, well, here it prints on 1 line, but it's really 2 lines and the screen is just printing it on 1 line. But it prints me the 2 things that I asked for. If they exist. If I would type something that doesn't exist, then it would print the one that it found, and the one that it didn't find, it would print me can't find. But if it found both of them, it prints me both of them. That's what ls does. So if I'm back over here at this example. It printed F2 and F1 over here. And then that as a stream went into WC. And WC saw it as 2 lines, 1 line containing F2 and 1 line containing F1, so it printed two lines. And why? In 2 words, because each line had 1 word on it. And 6 characters, because at the end of each line, there's a new line. There's a /n, there's a new line at the end of each word, so it's 3 letters on each line, 6 in total. So it didn't work, it didn't do WC on the files, it did WC on this string that it got. It didn't know what that stream means. But if I wanted to do WC on those files, as files, then I have to be on the right side of WC. Then I have to do WC file 1, file 2. So I use xargs for that. So now WC, in the second example, WC is as though written over here, F1 and F2. So it does the full output of F1 and F2, the tab here is by mistake. And then, and the total. Another example, find in the current directory, any file. And then execute the command grep for the word George on what file? On the file that I found. Now, there's a certain problem with this example. What's the problem with this example? What if I have a file called hello world? There's a space in that file. In the name of the file, there's a space. So what's going to come out over here is grep George from hello and grep George from word. Now, as long as George is not in those files, I won't notice any problem. I mean, it'll tell me no such file. Actually, it'll tell me no such file hello and no such file word, because there's a file called hello world and no file called hello and no file called word. But it doesn't know, because the find just printed me hello world, and the hello world went over here. It's as though hello and world. So how do I tell it? No, group that as one word. So in order to do that, I have to do the following. I have to do the example has to change to be like this. I have to add print 0. And then print 0 means at the end of every file name, print a 0. That's what that means. And find, I'm telling him, print 0. Print a 0 at the end of every file name. And then there's a special flag for xargs, which says don't delineate the parameters based on spaces, which is the normal way. And then the space between hello and world has a meaning. Instead, delineate the file names by the 0 or the null. So first I tell it print a null, and here I tell it delineate based on nulls. So now it'll see hello world as one file. What's the R? Normally the command is run once, even if there's no input, the R prevents that. Xargs has a weird quality to it, which I never really investigated, but you guys could investigate, which is that it automatically executes at least once, even if it got no input. So if I write xargs grep George and there's no files over here, it'll still do grep on nothing. And it won't give me anything, but it'll try running. It'll try running grep on nothing. As though I wrote grep George enter. And I don't want to do that. So I print this minus R. Now, this was all because I was using find and I was trying to execute things. There happens to be a built-in way within find to execute things. And that's this. So I could do the before we get there, first I'd do the same example again. Find in the current directory, anything whose type is D. What is D? Directory, xargs, change mode 755. So anything that's a directory, I want to give it what rights? What's 755?
Read, writes, execute.
Right.
And 5 is 110. Then read.
No, 5 is 101.
Read, execute, and then read and execute.
Read and execute for directories. Why does that make sense? Why would I actually, that makes sense, this example. Why would I want read and execute for a directory? What does it mean to read a directory?
You want only the owner to be able to change it.
Only the owner will be able to change it, but why do I want to let the whole world read and execute it? What does read and execute mean by a directory?
What's that?
Reading a directory means listing its contents. And executing it means going into the directory. If I want to go into the directory and then go to the next directory, if I don't have execute, I won't be able to go down. I won't be able to go down the directory path if I don't have the execute. But I still can't do anything like delete a file or add a file if I don't have write. So that's protects me, but it gives them access. They can see what's there, but they can't touch. So I want to do that for everything, but only the things that are directories, because I maybe don't want people to read my source code. I don't want them to read all my files. So on all my files, I don't want 755, but on the directories themselves, I don't mind if they see the names of the files. So And in this directory, I change this mode to 755. And of course, it's as though I wrote change mode 755, file name, file name, file name. Please go on the xargs, put everything to the right. But I can do this without xargs because find has a built-in -exec command. Which basically I just say -exec, change mode 755. And then I write this parentheses. And whatever I write in the parentheses is like what I found. In other words, what I found, those where the parentheses are. And then I have I have to write / semicolon. The semicolon, I really want to write semicolon, but the semicolon will be removed by the shell, so to make the shell not remove it, I have to write a /. But I have to write a semicolon to tell it the end of the command. So the parentheses indicates the files found. The parentheses needs to be / so the shell will not attempt to interpret it, will not remove it really. I find the xargs version more readable. I actually prefer the xargs. But this is also, because it's hard to remember this exact syntax. That is parentheses, / semicolon. But you can remember. But the second version will change. Here's a slight difference. The second version will change the mode of the subdirectories even if they were previously access denied. xargs will only affect the subdirectory's modes if the directories were previously accessible. In other words, the xargs will only work if I could get there in the first place. This will work even if I couldn't get there. Okay, that's the end of this lecture. I think we'll take a break here a little early. Wait, when is our class over? All right, we have another half hour. All right, I was thinking it's not an hour. I'm sorry, I thought this was an hour, 2 hour, 3 hour class.
Until 7:50, though, we have to take a break in the middle.
We'll stop early, but I want to do, you know what I want to do actually before we break? I want to do, check my schedule. According to my schedule. Yeah, we have 10 more minutes and then we have a break. So it's in the 10 minutes that we have left, I want to go over a little bit regular expressions. Because it's an important thing, and I think that
Apparently some people don't know it. So,
apparently some people don't know it. Yes, even Tusk, you don't know everything.
apparently.
So first of all, do you know this website? Regex
101.
101. Very good.
You know.
So does anybody have, did we see this in the video? I think I probably showed it in the video. I might have. Can I make this bigger? Here. So regex 101 is like, I can do like this. I can type like here. Hello world. World. And then I can write world. I spell whirlwind.
WI.
All right.
WHI.
WHI, yes. Okay, and I don't know, fish, it's and okay. So I can write a regular expression here and it will tell me what I found. So if I write H, it finds me, it tells me all the H's. If I write HT, there's nothing there. HE, it finds. Oh. Now, what if I write HELL? So it found that. But what if I write like this? I want to write like this. HE followed by, what does this mean? What does that mean?
Sorry. Or character by HC.
So why did it find me HEL?
Because it found a character between A and Z.
Exactly. It's just. But let me give you another example. Here. Help.
Help.
And now it found me help also. What if I write like this? A to Z. It found me both help and help. True? True. What if I want to find only hell and not help? Why? Because I want to find the. Here, Tess, this is for you. I'm trying to think of something you might not know,
Okay.
but maybe you know it. How would you find just the hell and not the help? But I don't care. I also want to find here. I also want to find I don't know. I want to find head too.
Wait, what are you exactly
He
asking?
wants to not.
I want to not find help.
Okay.
But yes, find hell and head. What is this common denominator between them?
What that is?
That the second letter is the same second letter. But I don't care which letter it is. I don't care if it's a double L, a double D, a double anything.
Oh.
I want a
Yes,
double.
braces, 2 close braces.
Oh, close. Wait, I don't think you're right. You're very close. Wait. So what did I say? Brace it? Parentheses.
No, yeah, put after the brackets, I think it's 2 in braces.
Wait, I'm sorry.
Brace, open brace,
Like that?
Yeah.
A 2?
2 close brace.
No, that means that's a multiplier. Very good. That's a multiplier. That means 2 of any character. But that's also help is I have any character.
You want to find help?
I don't want to find
He
help.
doesn't need help, guys, he doesn't need help.
I don't need help. Here, for example, HE11, it won't find. Why won't it find HE11? It's not 11 is not a character, it's a letter number. So it's kind of right. That's called a multiplier, that 2, but that's not right.
I'm gonna make a back reference.
So here's how you do it. You have to say capture group. It's called a capture group. Capture group, what I found, that's a capture group. And now I say \1. That means the first capture group that I found, I want to find it again. I want to find the thing that I found. I don't care what it was, but I want to find the thing that I found.
Is that like a regular expression, like you could do a DFA with that?
I don't know what a DFA is. No, we're not in that course. We're not in that course.
No, but if you can write it as a regex, you can for sure write it as a DFA.
But I don't know if that's there, because that's not all.
I don't teach that course.
So, but the thing is,
Okay.
yeah.
What?
Yeah.
What?
Did you say yeah?
No, I don't teach that course.
Wait.
I haven't taken that course. I haven't studied that course in 30 years, so. But I know.
Some of that course.
I'm just showing you that the regular expression is more than what you saw in that course. It's a lot more. And you have to watch my videos on it to get more of this. So here's the capture group.
And then you do $1 to do it again.
And then let's say I have 2 capture groups. Let's say I dafka want that number followed by 0 to 9. I want to find it followed by 0 to 9. So let's put and then I want here. Oh, but now why does it say in red?
Because you have to define.
Because I haven't had a second capture group. Did you guys watch these videos? So what is this gonna, can anybody write for me a regular expression that will match that? Nothing here matches it. Can you write me one that matches
Unless you
it?
want a word that matches that?
Give me give me an expression, give me a word here that matches that.
Okay.
Well, it's gonna start HE.
E00E.
E. Ooh.
Let's
maybe.
try it out, do it.
Zero, zero, E.
Boom! Boom, I'm amazing, everyone give me your own applause.
Because you wrote the E at the A, yeah, that's right. You understand?
I
Because
totally understand.
this is the 0 that he found. And he found it again, the second capture group, and then he went back and found the first capture group. Very good, exactly right. Now I have a harder one. I want to do the following. I wanna find a regular expression for a password. I want my passwords that people give me to be at least 8 letters. I want them to have at least one capital, one lowercase, and one digit. Isn't that reasonable?
Very weak password.
Very weak
That's
password.
8 digits, that's
At
it.
least 8 digits. Okay, when I make it 12, make it 12.
That has to have an emoji in there too. That's technically two characters in the
Anyway, 12 characters. You want 12 characters? Doesn't make any difference. 12 characters. I want to be one capital, one lowercase, and one anything. No, one capital, one lowercase, one number. So let's first write something that fits. Let's say hello, capital K to capital D, a number. And how many is that? Let's stick to 8. It's easier to.
Yeah.
It's easier to count. So there we have. I want to find a regular expression to match that and not to match. Okay, so guys, can you help me here?
Alright, start with the brackets.
Start over the bracket. We got to get 0 to 9.
Wait, whoa. Read the word, hold on. Well, you can't jump into that so fast. Sorry,
You can edit it after.
What you need to do is you use any character, any number of times, all the way at the beginning. We have to start with that. Any character, like a dot, asterisk,
Okay. Dot.
asterisk. And that's gonna be in between every one of our clauses.
Okay. Dot. Now dot asterisk means 0 or more characters. Right?
Google one.
No.
So now you have the same problem that now you have to jump after a letter.
Yeah, well, you can.
Yes, but
It's one
you're not
problem.
forcible.
So. I think we can do it in any possible order.
What do we want?
Check all permutations. Yeah, this isn't really like regex friendly, because you have to check all the possible permutations.
No, it's very regular expression friendly. You have to have what's called a forward,
Forward look ahead,
look ahead kind, yeah.
that's like made up stuff.
A forward look ahead.
It's not regular expression.
Yes, it is.
It's really expression, it's not like it's.
What you learned in that other course is,
Context.
you learned the concept of regular expression, but you didn't learn. Whole-
Defining the concept.
What?
Take a break from it.
Well, I think we're finished, actually.
Oh, that's excellent.
Yeah, we're finished, yeah. So you'll think about that.
I'll
It's
think about
actually in the slides. But you'll think about it. This is very close to being finished, but it's not quite.
When you say we're finished, like, that means what? That means you guys are.
Well, we have a lab after this.
You need a lowercase letters.
That was the lecture. The lecture's finished. The lab is at 7:05.
All right, see you.
Lowercase.